Good evening. I'm going to present about code coverage and code testing, but I'm going to start this video with code coverage. The next part of the video, that's part 2, will be about code testing. So let's start with the first part. Part 1 is going to cover code coverage using clover. I am Dennis Kisina, so let's get straight to it. So what are we going to cover during this short presentation? I'm going to talk about what code coverage is, how code coverage works, what is clover, what problem does clover solve, what you can do with it, that is clover, how it works, and what options you can configure. Then we shall conclude the whole video with a brief demo of how clover works. So what is code coverage? You can define it in 2 ways. I'm going to define it in 2 ways to make it a bit more clear. So code coverage is the percentage of code which is covered by automated tests. This metric aims to measure the number of lines covered by the test cases you have for your code base. Okay. Code coverage is a measurement. This is the second definition, how you can look at it. Code coverage is a measurement of how many lines or blocks of your code that are executed while the automated tests are running. Okay, so that is code coverage. How does code coverage work? It can be done in 3 ways. I'm not going to go into the details of the last 2. I'm going to concentrate on the source code instrumentation. I'll just briefly read what is here for the next 2, but we shall go into detail about the source code instrumentation. So source code instrumentation is a technique actually where let me first read this. What you should note is a technique. This approach adds instrumentation statements to the source code and compiles the code with the normal compile chain to produce an instrumented assembly. I have an example on the next slide which I'll show what I mean by the instrumentations added to the code as it is executed. Okay, then you can have a clear understanding. The other one, how code coverage works, you can use intermediate code instruments. Here, the compiled class files are instrumented by adding new bytecodes, and a new instrumented class is generated. That is another way how you can do code instrumentation. Excuse me. Runtime information collection. That's another way how you can do code coverage. This approach collects information from the runtime environment as the code executes to determine coverage information. So let's have a clear understanding of how source code instrumentation works. And this is how clover works, that we are going to look at later on. So what is clover? Clover is a coverage tool and testing tool for Java and Groovy code. Clover uses code instrumentation, as I've told you already. So as you look here, this is your source code. Even this if statement, this is your source code. But what clover will do, by that I mean adding source code instrumentation to your code. It will, as it is executing the code, it will add this instrumentation, temp 1, temp 2, temp 3, temp 4. as the code runs through the JVM as it's being executed. This is what it will use to determine the coverage, the test coverage of your code. That's what they mean by the source code instrumentation. So the next part is, or what we need to cover is, what problem does OpenClover solve? So OpenClover solves a couple of problems. I'm going to just highlight a few in this. OpenClover helps to show teams, because when you're developing your code, you'll have very many teams developing on different components of the code base. What OpenClover does is it will help teams to have a general overview of which areas of their code that has been tested and that needs to be focused on, and which areas they need to focus on in terms of testing, which ones are not being tested. Also, the other thing with code clover is to help you to monitor your automated tests as the code base grows, especially given that, for example, given that you are doing agile development, these incremental releases, so the code base will grow rapidly and there will be a lot of changes. So you need to track if you are doing proper testing, if everyone is really doing proper testing on the code base. That is one of the reasons why you do want to use a tool like OpenClover. So what can you do with it? There are several things you can do with OpenClover. You can integrate it into numerous tools like Bamboo, Hudson, Jenkins, and builds like Ant and Maven. You can also run OpenClover in Eclipse, IDE, or IntelliJ. Okay. How does it work? I've hinted on this, but I can still just highlight a bit. As you saw, when you run your tests, OpenClover will add the instrumentation on each line of code. So when it runs a line of code, it will generate a matrix based on different things, the blocks of code, the statements, the methods. In this, when it will do several calculations and generate reports based on the methods, the statements which have executed and which has not been covered, and classes in your whole project. And these are the metrics you'll have a look at in your dashboard. Okay, so it works through your dashboard. It will generate metrics in the dashboard. What options can you configure with OpenClover? There are several. You can configure for it to look at statements. The statement coverage measures whether each statement is executed. Branch. These are your conditional statements or methods that are in your code base. So you can look at all these matrices and you see, and you configure based on what you want to see and what is of interest to the project. Okay.